Hello, my name is Mikayla, and I am presenting today the stigma around cattle methane emissions. I want to start with that I do believe in global warming, and I think it is a serious issue that needs to be addressed. But the media paints agriculture, specifically animal agriculture, in a light to persuade readers not to consume beef. My goal of this presentation is to change the narrative and reveal the truth behind cattle methane emissions by discussing how methane emissions relate to cattle, the importance of animal agriculture, mitigations to reduce methane emissions, and why methanogenesis cannot be eliminated in the rumen. The methane is a greenhouse gas that can quickly heat up our atmosphere by entrapping heat from the sun. Methane traps 84 times more heat in 20 years than carbon dioxide does. However, it has a short half-life and lasts in the atmosphere for only 12 years compared to carbon dioxide that lasts hundreds of thousands of years, according to the Food and Agriculture Organization of the United Nations. The image on this slide was on Bill Gates' blog because he is an advocate for reducing greenhouse gases. The figure depicts that if cattle were a country, they would rank third in greenhouse gas emissions behind China and the United States. This is an example of what I mean by the media painting cattle production and the consumption of beef in a bad light. This next chart is from the International Energy Agency methane tracker. Anthropogenic methane, which is human source methane, is a dark blue color, and as you can see, agriculture is in the lead. However, it is important to note that transportation, plant sources of methane, fertilizer, deforestation, all production of animals, and many, many more factors are included in this, not just cattle. The point I want to make is that methane emissions is a serious and growing problem, but animal agriculture does not need to be the primary focus for the initiatives, and throughout this presentation, you will find out why, hopefully. According to the Department of Economic and Social Affairs, the population will reach almost 10 billion by the year 2050. With our rapidly growing population, the efficiency of growth in livestock is crucial for food security to meet their growing nutritional demands. Ruminants can utilize unpalatable and undigestible feeds such as forage to produce meat, milk, and fiber that humans and most other animals cannot utilize. They then in turn provide us with important sources of calories, proteins, and micronutrients from their meat and milk. So what if animal agriculture was eliminated and our only source of nutrients from a plant-based foods? Well, Robin White and Mary Beth Hall from Virginia Tech's Department of Animal and Poultry Science conducted a research model to quantify what exactly would happen. The results are as follows. Plant-based diets can have health benefits on an individual human basis of reducing the risk of coronary heart disease and obesity, according to the Dietary Guideline Committee. However, on a growing population basis, it is not feasible because micronutrient requirements cannot be met. So now that we have seen what eliminating animal agriculture would do to food security, let's move on to what they found would happen if animal agriculture was eliminated for greenhouse gas emissions. The model they used was accredited 49% of greenhouse gas emissions from agriculture to animal agriculture specifically, and they found by eliminating animals from the equation only led to a 2.6% reduction in methane. But how could this happen if cattle were a country and would be the third largest producer of greenhouse gas? Well, what people do not realize, and quite frankly, I didn't even think about before doing my research, is that there are trade-offs that have to occur. The trade-offs include having to increase in fertilizer use to replace animal manure, disposing in animal byproducts that were previously used to feed animals, and having to produce crops on lands that were formerly used by grazing ruminants. This trade-off is not what many scientific sources think about either, or mainstream medias. And so when their simple solution is to stop eating beef altogether, it's kind of questionable. So now let's move on to why ruminants produce methane and why eliminating methanogenesis from the rumen is not a viable option for the animal. Enteric fermentation occurs in the rumen of ruminants, where the microbes that inhabit it produce the byproducts methane, but also volatile fatty acids that the animal utilizes for energy. The microbes are specialists in the type of feedstuff they ferment and what byproducts that they produce. The microbes that specialize in cellulose fermentation produce the most greenhouse gas by fermentation. The fibrolytic bacteria, such as Ruminococcus albus, yield cellodextrin and cellulobiose in the rumen. And succinate that produces CO2 and acetate that make hydrogen are both being produced. The methanogens use hydrogen and keep the partial pressure of the rumen low, so methanogenesis in the rumen are imperative to gut health because if methanogenesis is completely reduced, cellulose degradation in the rumen will stop and there will be back pressure buildup of fermentation. So there are mitigations put in place to reduce methane emissions from cattle. As I discussed on the previous slide, you cannot eliminate methanogenesis in the rumen completely, but mitigations can have positive environmental and economic impacts. The economic impacts to the producer is because the cattle will be more efficient and not lose as much energy. Some methane mitigations include feeding a more carbohydrate-rich diet, adding prebiotics, unsaturated fat added to the diet, ionophores, and many more. But one mitigation that has recently been introduced to the industry, and I want to discuss to the class, is feeding red seaweed, which is a natural anti-methanogenic. Robert Kinley and his colleagues conducted a 90-day feed trial, adding dried red seaweed to the diet in increasing percentages and seeing very positive results. The results were mostly positively seen at 0.10% and 0.20% of Aspergillus taxiformis added to the diet, with a 40% and 98% methane emission reduction. It was stated that there were no negative effects on daily feed intake, feed conversion efficiencies, or rumen function. However, the feed trial was just for a 90-day period. If you were to continue to feed the antimicrobial seaweed, rumen function will be affected negatively, as previously stated. If it wasn't affected negatively, that would be great. It would be the solution to all of our problems. But to conclude, methane emissions are a real problem, but they should be reduced in all sectors of our economy, not just agriculture. I hope you have learned how much of a vital role animals play in meeting nutrient demands of our growing population, and to understand that mitigations have been put in place, but methanogenesis cannot be eliminated in the rumen. And here's why we're excited. Thank y'all so much for listening.